All right, if you're here for the worker noise exposure webinar, you're in the right place. We'll get started in just a little bit. There are a few other people that aren't here yet. Let me get going. All right, so thank you for joining me for this webinar. I'm going to go pretty quickly through this. Sorry for my voice. I'm suffering from allergies right now. I'm going to go pretty quickly through this. So if you do have questions, please use the chat feature on the right, and I'll slow down or go through things in more detail if needed. Just a reminder, it's best if you don't multitask to get the most you can out of this. Yeah, okay. I think that's it. So we are dealing with factory noise. The goal of this is just understand why it's important, how to compute exposure, convert between the dose and the 8-hour exposure, and then talk about noise mitigation. Also, feel free to write in what your background is so I kind of know my audience a little, but I'll assume you know some about acoustics and slow me up if you need me to go in more detail. So soundproofing can be tricky. A lot of times there's hard surfaces that need to be washable. Could be dust, there could be dirt, and acoustical absorption sometimes is a little tricky or you just need special treatments. You can't just use fiberglass acoustic panels or hung ceiling a lot of times. Usually they have large volumes, moving equipment that can keep baffling, or some kind of ceiling system, make that not practical. And many times it's pretty loud equipment. The reason we want to protect people's hearing, or why we want to reduce noises, is to make communication easier. You can be less productive if communication's not that clear, and it can be hazardous. And of course, you can cause permanent hearing damage. This is the OSHA noise exposure. This table G16 is kind of their standard table. And they state that this is the US Department of Labor, Occupational Safety and Health Administration. They state that when an employee is subject to these limits, or noise levels in excess of these limits, you really have to use some administrative or engineering controls to reduce that noise. You can't just put in a little hearing protection. So any noise levels above 85, so of an 8-hour weighted exposure above 85, you need to have a hearing program in place. So in most cases, the goal is to get it below 85, because these programs can be costly and a nuisance. They need to do hearing checks on people. They have to do training. Ideally, the noises you'd like to get below 85. Now, 85 isn't a magic level. It's the 8-hour exposure. So we'll talk about how that's calculated. You can get a lot more exposure if it's for a lower duration of time, and you add up all your exposures to come up with what is your dose, or your 8-hour equivalent exposure. And again, 85 and 90 are our goals. So this dose, the accumulated percentage, or the exposure that you have, is calculated here, and I'll talk about this. But it's important to calculate this. You can just grab a dosimeter, a sound level meter, and it will automatically, you tag it to a person, just put it on a person, have them wander around, do their activities all day, and it'll give you a dose by the end of the day. And that's great. It'll tell you if you need a program, what kind of program you need, what issues you have, but it doesn't help us mitigate the noise. So you really want to calculate how much time they're spending in each area and what is that level. So let me just see if this is on our website that I'll send you to, the blog. I threw in a couple other tables. They're pretty long, so I didn't include them here. But it has a conversion between sound level and this T. It's, how many hours can you spend at each sound level? So 80, I guess it gives you this, but in more detail for each level. So you can, if you're exposed to 90 for 8 hours, that's your complete dose. If you're exposed to more for less, you add that in and you come up with what is that overall exposure. You can also convert between that 8-hour time weighted average and your dose, or the percent noise exposure. So once you have this dose, if you say, all right, I have 50% exposure, well, that is equivalent to an 85 dB 8-hour exposure. And that will, require your mitigation at that point. But what we need to know is, where are they getting that? Are they getting it from, it's not necessarily the loudest area that needs to be treated, because it depends on how much time they're spending in each area. So once you identify where, so this is what we usually do, is we'll go in and survey the different areas, just do a mapping of the facility. Here's the noise levels in the break room. Here's the noise levels in the, by each piece of equipment. And then we survey, and then we just interview the workers and say, hey, how much time is spent in each area for each different type of worker? And then we compute what that dose or exposure is. We're looking for what are the biggest, and it's a little tricky because you look at what is the biggest contributor to your dose, but then you're also looking at what ones can you easily treat, or what ones are treatable to really make an impact and reduce that exposure. As far as mitigation, you have a few options. One is treat the noise source. We're going to go through each of these. Treat the noise source, treat the path, treat the receiver, the person or the worker. And then you have time is another tool you can use as far as limiting exposure in different areas. Sorry for the last 6 things on one slide. You can always swap out equipment. I mean, that could be an option, swapping out equipment, just updating equipment. We've seen big changes in noise levels just with servicing equipment. Sometimes you can enclose it or wrap certain parts of the equipment. A common practice is this barium-loaded vinyl, just the heavy vinyl. It's best if it can be decoupled from the system. So instead of just putting the vinyl flat on it, it's this damped material that will help. But if you can put a quilted or fiberglass layer between the source and the lagging, that'll give you additional attenuation. Enclosing equipment, you have to be careful with heat transfer if there's any ventilation needed, but in a lot of warranties get thrown out if you start modifying the equipment or controlling the operating area, but that can be an option. Even just treating part of it, the exhaust stack or some portion of the equipment. And then possibly location of equipment could be a treatment. Isolating some of the, if you have 3 units, if you can isolate them so you're not getting the noise from each of them at a work area, you're just getting the noise from the one you're working with. The path is another option. There are 2 paths, and it's really important to separate how much noise you're getting from each path. The direct path, which means if you were to knock out all the walls, remove the ceiling, and you're just in a field with this equipment, that's the direct path. There's no reflections. It's just from that source to the receiver. And then there's the reverberant reflected path, which is everything else. So if you get rid of the direct path and we're just dealing with secondary reflected paths, that's our reverberant paths. And of course, why this is important is your treatments are different. If it's a direct path, then a barrier could be useful. You could block the line of sight, and that could provide some attenuation. If it's reverberant or a reflected path, well, the line of sight has nothing to do with that. They'll have no, it'll have no impact because it's all coming from reflected paths. And absorptive treatments will be effective in that case, where you're trying to attenuate the reflected paths. So when noise hits a surface, it's either reflected, absorbed, or transmitted. With a barrier, we're trying to reflect or block it, reflect or absorb it. With the reverberant path, we're just trying to absorb. And so, of course, if the direct path is the issue, throwing absorption all over the facility will have no impact. You're just, you're not affecting the direct path. So you want to know the difference, and you can calculate the direct path, the noise level at a position based on, this is the sound power level of the equipment, but it doesn't even matter because it's just the contribution from the distance, the direct path, and the reflected path. I guess I'm not going to go into more detail there, so let me just break that down for you. The Q in this case is I guess it's the directivity coefficient. So if it's in free space, if there's no wall right next to it, it'll be a 1. If it's a half spherical, like if it's on a reflective surface on the ground, it's on a hard ground, that'll give you a 2. You could be getting a 4 would give you if there's 2 reflective surfaces. So if it's up against a wall in the back and it has a hard floor. So those will increase the direct noise that the reverberant has nothing to do with if it's right up against these other hard surfaces. And then the R in the reflected, in the reverberant, that's the room constant. And it's calculated based on the surface area and the average absorption of that surface area. Now you can measure this. If you go into a space, measure the reverberation time, then you can calculate out the room constant. We rarely do this in industrial spaces. It's usually we just model it or estimate it, and you can come up with how much of the path is reflected. So at any position, of course, there's software that will do this as well, but it's good to have an idea what this is coming from. If you have 5 pieces of equipment in the room, at any position, you'll have different direct path distances and different, the reverberation part will be the same no matter where you are. It'll just be the direct path that will be the issue. And if there's blockage between you and the equipment, then we're dealing with just reverberant noise. So you should be able to calculate or estimate throughout how much of the noise is from a direct source, how much is from the reverberant, again, to be able to calculate. Oh, here we go. Offering audiology testing. Yeah, great. Yeah, there's a lot of need for that. And what I usually get called in to try to avoid that. It's companies that want to avoid doing noise treatment plans or just trying to reduce the exposure. We've had some facilities that they're actually in compliance with OSHA, but they just want it to be a better environment so the communication is easier, and they want to reduce the noise there. Receivers is your other, or one of your other options. So you can treat the source, the path, either reflected or direct, and then the receiver, and that's hearing protection. Sometimes there's some kind of booth people could work in, or some kind of shielding that they could have on their person that's a portable. This isn't always ideal. There's custom fit earplugs. You can definitely, where they take a mold, fit them in each individual. But again, that's not going to help with communication. It still becomes it's a loud environment. And then the last option, really, if you can't treat the room or treat the source, is limiting the time in certain areas. And that might be the easiest. Split up shifts or just shorten exposure in different areas and work more in other areas. And that, that's another option to limit the exposure if you feel if the company feels it's not cost effective to treat. I usually tell people you can acoustically treat any source. It's just a matter of cost usually that makes it difficult. And so it might not be practical to do a lot of treatment. The other thing I was going to bring up with reverberant paths, there are absorptive treatments that are washable. You can bag your absorption, like fiberglass absorption in Mylar, and it's still acoustically effective. There are baffles that can be cleaned. There is acoustical absorption for harsh environments. They're going to need to get replaced more often, though, because once you clog up, the pores or clog up the absorption, the absorptive treatment, it's not going to be effective. And so in some environments, they're not going to last as long. Just, depends on the space. And I guess that's it. So Noise Expert, we're independent acoustical consultants. We don't sell products, or we just consult. And we do environmental, room acoustics, mechanical, any kind of noise issue, product noise, even industrial noise, we get called in to help with, and expert testimony when it comes to that. We're DBE, and we'll be glad to team with anyone if they need some help. So any questions on that? I can, let me stop the screen sharing here. I'm going to actually send you to a page. I'm not going to stop the broadcast, but I'll redirect you to our blog post. You should be able to get back to me as a tab. But that blog post, if you scroll down to the other tables, the second table, so the first table is that brief summary of here's the duration that you're exposed to that noise. And this is just never the case. You're usually not exposed to a noise level constantly for a 8-hour, 12-hour period of time. It's usually, some exposure at a higher level, then exposure breaks, or exposure at different levels. So that the next table is just a breakout decibel by decibel, how much time you can spend there. And that calculation, Yeah, what did I want to say there? Yeah. Okay. And that calculation, they're looking at, exposure in each different area. And then the next table is a conversion from percentage noise exposure, the dose, to that 8-hour time weighted. So 100% exposure is 90 decibels. 50% exposure is 85. So, I mean, not that it's critical that you have one over the other. You know, if you have 50% exposure, you need to do something. If you know you have 85 or more, you need to do something. And you know, if you have 100% or 90, that you really need to take some strong steps. All right, let me just see. But yeah, please let me know if there's any other questions. Let's see if I wrote any down here. Some resources. I guess I didn't update that. Some resources. You know, the OSHA site. I mean, if you Google OSHA noise exposure, it'll give you those tables. You can also pull them off of our blog post there. All right. Feel free to shoot me an email, give me a call. Let me know if you have any questions. I hope you got something out of this, and take care. Bye.